tangent of u, and u is v minus 1 over v, and v is natural log of x. What is the value of dy dx at e? This is a real AP problem. So, two ways you can do it. One, you could plug in each piece, like you could plug it all in. I think it's a little tougher that way. So I'm just going to work with finding the derivative of y. Would you agree that the derivative of tangent of u is still tangent, or sorry, it's secant squared of u times what? U prime. Okay, easy enough. Any questions so far? Well, secant squared of u, which is v minus 1 over v, or natural log of x minus 1 over natural log of x. So far, so good. Times the derivative of that times u prime. I would, if it were me, at this point, I probably would look here, but you could do another set of derivatives if you wanted to. So this would be 1 over x. How would you do the derivative of 1 over natural log of x? Push the rule, or you could do natural log to the negative 1 and do a chain rule. Either way, you got to do one or the other though. Low d high, which would just be 0, minus high d low over low squared. Any questions about how I got there? Pretty yucky. Yeah, this changes to a plus. Now, what's nice about the problem? I'm going to plug in e. What is natural log of e? So what's 1 minus 1? 0. So I get the secant squared of 0, which is 1, right? I just will note that. 1 over e plus 1 over e divided by, what's on the bottom there? 1. So I get 1 over e plus 1 over e, which is 2 over e. That was a pretty nasty one. I don't know if you even need to see the second one or not, but we'll do it. Any questions about the first one? Like I said, it's pretty nasty. 16x, is everyone okay with where I got 16x? What am I looking at when I'm doing this problem? Calculus helper. And you know you don't have to have this one memorized yet. So it's one that I'll either give you the formula or something. 1 minus u squared, right? And we can simplify it. I'm not going to, but we can. Last one. Review limits. How do you start a limit problem? Plug in 4. And if you plug in 4, you get 0 over 0, which lets you know more work to be done, right? And so, does it factor? And now I plug in 4, and I get 8. I kind of hope you always do that one that way. I think it's pretty easy, but today we're going to learn some shortcuts to problems like this. Today we're going to learn what's called L'Hopital's rule. L'Hopital's rule is a way to simplify limits, especially ones that get really yucky. L'Hopital's rule currently is not in AB Calculus curriculum. It is only in BC Calculus curriculum, which does fit you anyway. But I actually have always taught it in AB anyway because it makes limits easier. Why wouldn't you, right? So it is technically BC curriculum, but it's pretty easy. L'Hopital's rule says that if you have a limit as x approaches a of two functions divided by each other, f of x divided by g of x, then that equals the limit as x approaches a of the two derivatives, f prime of x divided by g prime of x. This only works if you have a 0 over 0 limit or an infinity over infinity limit. And those are the ones we need help with anyway, right? For the most part. So if we can get it in this format, either 0 over 0 or infinity over infinity, we can take the derivative of the top and the derivative of the bottom and then try to limit again. We are not doing a derivative of the function, so we will not be using a quotient rule. This is just a trick. So we're just going to do the derivative of the top and the derivative of the bottom, not the quotient rule, and then do the limit again. That's called L'Hopital's rule. So, revisit the bell ringer. Oh, is it x minus 4 on top? And x squared minus 16 on bottom? No. Backwards. Sorry. Would work either way. What's the derivative of x squared minus 16? What's the derivative of x minus 4?
I need 1.
Any plugging 4? That's how low it's possible. Did we get 8 on the bell ringer? Same thing. I don't think that L'Hopital's rule simplifies this a ton because factoring was so easy on it. But can you see how L'Hopital's would really simplify your life? But you didn't know derivatives. Okay, so that's what we're learning today, L'Hopital's rule. The proof of L'Hopital's rule is on page 448. If you want to look at that later, you will see why it has to be in the form 0 over 0 or infinity over infinity for L'Hopital's rule to work. So, these are 7 limits, many of which would be very difficult. Would you agree? Step 1. Plug in 2. Do not use L'Hopital's rule without plugging in 2. Why do I say don't use L'Hopital's rule without plugging in 2? Because it only works if you get 0 over 0. You'll mess it up, right? So plug in 2. 2 squared is 4. 4 times 3 is 12. 12 minus 14 is negative 2. Negative 2 plus 2 is 0. And I get 2 minus 2 on the bottom. So is this a candidate for L'Hopital's rule? Yes. Mental note, I did get 0 over 0. I can use L'Hopital's rule. So this is the limit as x approaches 2 of the derivative of the top, which is, and the derivative of the bottom, 12 minus 7. That one was faster with L'Hopital's rule, because that factoring would have taken you a little bit longer. Right? You have to do the factors 1 and 3 and the factors 1 and 2, see which ones add to give you 7. Wouldn't take you too long, but a little longer than L'Hopital's took. On the next one, it is x approaches negative 3. Yeah. So the limit is x approaches negative 3 of x plus 3 over the square root of x squared minus 5, then outside the square root minus 2. Plug in negative 3. I get 0 on top. 9 minus 5, which is 4. The square root of 4 is 2. 2 minus 2 is 0. So again, I get 0 over 0. If I were going to do this prior to L'Hopital's rule, what would I have to do? Multiply by the conjugate, the square root of x squared minus 5 plus 2. Not impossible, but a little bit more work on this one. However, L'Hopital's is a little bit more work on this one. Would you agree? Why? I have to do a chain rule. On top, I just get 1, but on the bottom, how do I take the derivative of the square root of x squared minus 5? 1/2 x squared minus 5 to the negative 1/2 times 2x. Remember, I'm not doing the quotient rule. I'm not taking the derivative of the whole thing, just the top and the bottom. Now I can plug in negative 3 because I don't get 0 on the top anymore. Negative 3 squared is 9. 9 minus 5 is 4. What is 4 to the negative 1/2 power? 1/2, right? Well, let's do that without a calculator because these are non-calculator problems. How? Square root of 4 on the bottom. This half makes it a square root, the negative is on the bottom. So a half times a half is a 4. Times 2 is a half. Times 3, I guess 1 over negative 3 over 2. Everyone gets so hard. 1/2 times 1/2 times 2 times negative 3. And if you'd written negative 6 over 4, you'd be fine. So what does that equal? Still a lot of work, but would you agree probably a little less work than conjugates? If you're good at taking derivatives, a little less work than conjugates. 0 on the next one. What's anything to the 0 power? 1. So I get 1 plus 0 minus 1, which is 0. And 1 minus 0, or 1 minus 1, which is also 0. So is it a candidate for L'Hopital's rule? Not all limits are. Remember, if you get a number, you're done, right? But a lot of limits, especially the hard ones, were 0 over 0 ones. So this really opens up a lot of help. Okay, on the top I get e to the x plus 1. On the bottom I get e to the negative x. Does everyone know where the negative went? Feel okay with that negative 1 on the bottom? Times the negative 1, the chain rule. Plug in 0, 1 plus 1 is 2. Maybe 0 power 1. How hard would that limit have been by hand? Or by the long way? You would have had to change e to the negative x to 1 over e to the x, get a common denominator on the bottom, flip and multiply. It would have been fun. Changes into a couple minute problem, or a minute, maybe a minute. Hey, the limit is x versus negative 2. Negative 2 cubed is negative 8. Plus 4 is negative 4. Plus 16 is 12 minus 1, 0. 0 on top. Negative 2 cubed is negative 8. Plus 32, which is negative 24. No, positive 24. Minus 40, so negative 16. Plus 16 is 0. Do you have to do all of this in your head? Do you maybe have to do it without a calculator? Yes, but write it down. Write down the, do a little bit on paper. I don't have room up here, or I probably would. And I have y'all to tell me if I'm wrong. So.
You can give us one that's that difficult to do.
Absolutely. Yes. Definitely. So after that gateway quiz, I'm surprised that's a question you have planned.
I didn't even know it was that hard.
Really? Good.
This looks a lot like doing that math in my head is a lot.
But you could do it on paper. Right? Write down negative 8 cubed or negative 2 cubed. You can do it. Okay, plug in negative 2. Negative 2 squared is 4. 4 times 3 is 12. 12 minus 4 is 8. 8 minus 8 is 0. And then on the bottom, negative 2 squared is 4. 4 times 3 is 12. 12 minus 32 is negative 20 plus 20. Uh-oh. You're at 0 over 0 again. Do it again. Or I could something like this is horrible. This is not bad. Imagine having to factor that by grouping or something.
You just do as many times
As long as you keep getting 0 over 0. Yes. So I get 6x plus 2 over 6x plus 16. Plug in negative 2. Negative 12 plus 2, which is negative 10. Negative 12 plus 16, which is negative 5. I did. Now, could I have just started and found a bunch of derivatives? No, you have to check and make sure you got 0 over 0 before you can do it. Now, the beauty of this is the difficulty level of these in AB is held to a minimum because they keep it things you wouldn't have to have L'Hopital's rule on because it's not necessarily an option for everyone because L'Hopital's rule is not in AB curriculum. However, you will be doing the BC exam, so any of these will be better game. Okay, and let's look at the next one, infinity. Now, I imagine you all know the answer to this, and I hope you don't have to use L'Hopital's on this one. It's 4/3, right? But I do want to show you that you can use L'Hopital's rule. Again, don't use L'Hopital's rule on this. It's a waste of your time. But if I plug in infinity, would you agree I get infinity over infinity?
Yes.
So I can use L'Hopital's rule. I would get the limit as x approaches infinity of 12x squared over 9x squared. And I still get minus 7 and plus 8x. Which is the limit as x approaches infinity. Again, infinity over infinity, right? 24x over 18x. At some point, you probably see the answer, but hey, if you want to do the derivative one more time, 24/18, which is 4/3. Again, this is a case where L'Hopital's rule is a big time waste of your time, but it does work on infinity over infinities. If you came to an infinity over infinity that you forgot, maybe one that involved a negative or something like that. Okay, on the next one. If I were you, on the next two, if it were me, I wouldn't use L'Hopital's rule. I wouldn't do them the long way. Well, what?
Is like a derivative in disguise.
It is. Look at you go, right? Aren't those just derivatives? Both of them? So e to the 4 plus h minus e to the 4 all over h as h approaches 0. What's the function? And what is a? So this is f prime of 4, which is e to the 4. Now, could you have done L'Hopital's rule? Yes. If you did L'Hopital's rule, you'd get the derivative of that first piece, which would be e to the 4 plus h times 1. And then on the bottom you would get 1, and then you plug in 0, you'd get e to the 4. So you get the same answer either way, with L'Hopital's rule or using a derivative. On this one, another derivative, isn't it? Sine of x at pi over 4. So the derivative would be cosine of pi over 4. What is cosine of pi over 4? Okay, so could you use L'Hopital's? Yes. You could use derivatives in disguise. If you did L'Hopital's, what's the derivative of sine of x? Cosine of x. What's the derivative of a constant? Isn't sine of pi over 4 just a constant? So I've got cosine over 1, plug in pi over 4, you get the same answer with L'Hopital's or with derivatives in disguise. Now imagine your people in AB Calculus whose teachers don't teach L'Hopital's. They have to use derivatives in disguise. You have options. Okay, I'm going to pass out L'Hopital's worksheet, and there's a book page. The book page is written at the top of the homework, but the number 60 is not